Since scalar multiplication and vector addition is really important for this chapter, I want to go ahead and do a few examples. So for example 1, we want to use the figure here of vectors u and v to sketch the following. So for part A, we want to find negative 2u. So I'm actually not using this vector v at all. And before I find negative 2u, I'm just going to find negative u. So negative u has the same length or magnitude as u, but it points in the opposite direction. So that's negative u. Negative 2u would be twice the length. Try to double this length here. That looks pretty good. So this here would be negative 2u. So it points in the opposite direction as u, and it has twice the magnitude. For part B, we want to add vectors u and v together. So I'm going to take vector u and move it over here so that u and v are lined up in a head-to-tail fashion. And I'm trying to move u over here so that I don't rotate it at all or change the length. And then starting with the tail of u, I'm going to draw a line that goes to the head of v here. If you have a ruler, that would be great. So, oops. All right, so that there is the resultant vector. So that's u plus v. Now I use a triangle rule for this, but we can also do this using the parallelogram law. So for the parallelogram law, I'm going to move vector u over here so that vectors v and u have their tails connected. Then I'm going to draw a line that's parallel to u, but starts here at the head of v. And then I'm going to draw a line over here that's parallel to v, but starts at the head of vector u here. So now I have all the sides of the parallelogram. They intersect here at this point, which ends up being the head for my resultant vector. So to draw the resultant vector, it's going to start here at the tails of u and v, and it's going to extend over here to where these parallel lines intersected. Okay, so that there is the resultant vector, and we did this using the parallelogram law. So for part C, we want to do 3u plus v. So I'm going to find 3u first. So 3u would have the same direction as u, point in the same direction, but be 3 times the magnitude. Okay, so that would be 3u. And then I'm going to move that vector, try not to change the magnitude or rotate it at all, but I'm going to line these up again so that they're in that head-to-tail fashion. And then the resultant vector is going to start here at the tail of 3u and extend to the head of v. Okay, so that there is the resultant vector. That is 3u plus v. And I use the triangle rule for this, but you can also use the parallelogram law. Example 2, we want to go ahead and use the figures of vectors u, v, and w here to sketch the following. So for part A, we want to find u plus v minus w. So I'm going to do u plus v first, and then I'm going to add to it negative w. All right, so let's go ahead and add u and v together. So I'm going to move u so it's over here so that I have u plus vector v. So the resultant of those two will look like this. So this right here is u plus v. Then I need negative w. Negative w is just going to change the direction, make it point in the opposite direction. So that's negative w. And now I have this and I have this, so I have to sum them. So I'm going to just move u plus v down here, so that's u plus v, and then I would add to it negative w. So I'm going to do the head-to-tail fashion again, and then I'm going to go ahead and connect the tail of u plus v with the head of negative w to get the resultant vector u plus v minus w. So that's this line right there, that's the result. Now I also want to do this problem a different way where I connect u and v and negative w all together in a head-to-tail fashion instead of lumping these two together first. So we have, we have u, v, I mean, this is v. We have u, I'll put that over here. So I've got u, I've added on vector v, and negative w is going to look like this. So I'm going to move that over here, negative w like that. So now they're all connected in this head-to-tail manner. I'm going to start here at the tail of u and draw a line to the head of negative w. So starting with the tail of the first vector, I'm going to extend the line all the way to the end of the last vector. And this right here, that is my resultant vector. So that is u plus v minus w. Part B, I'm just going to do it in that head-to-tail fashion with all three vectors. So we're going to start with v. V is good. It's right here. And then I need 2w. So I need twice the length of w. So something like this. So that's 2w. So I'm just going to move it over here. Hopefully I don't change the magnitude or rotate it at all. So I have v plus 2w, and now I need to add to that negative u. I'm doing v plus 2w plus a negative u. So negative u would look like this, right? Points in the opposite direction. So I'm just going to put that right here. And then we're going to connect, starting here at the initial point of v and extending to the terminal point of u, negative u. So this right here is the resultant vector. That is v plus 2w minus u. All right, that's it for this section. Make sure you do the homework problems, and then I will see you in the next video when we start working with force vectors.